Welcome to the last video in the course. This is Chapter 15, Part 2. In Part 1, we looked at expected values where assigned probabilities and payoffs were used in a weighted average process to come up with expected values. In Part 2, we're going to look at decision analysis without probabilities. We're going to then dive a little bit deeper into expected value. And then finally, we're going to look at Bayes' probabilities and how that was used to actually compute the probabilities for our branch nodes in the expected value analysis. So oftentimes we will have probabilities and then we have confidence in the probabilities, and we then can do that type of expected value analysis we did in Part 1 of the lecture. Other times we may have little confidence in the ability of individuals to assess the probabilities we'll be facing, and in those type of situations, often we'll just use a simple best and worst case analysis, and that's going to be sufficient. There's two approaches. One is the optimistic approach, and that evaluates each decision alternative in terms of the best payoff that can occur. So in other words, we go to the best possible state of nature, and then we look at the best payoff in that particular state. The decision alternative that is recommended is the one that provides the best possible payoff. So in the case of Pittsburgh Development Corporation, the best state of nature would be strong demand. So if we look at the payoffs from strong demand, we notice that the maximum of the strong demand payoffs would be to build a large complex, in which case the company would net $20 million. So this is the optimistic approach. We look at the best state of nature, the maximum payoff in the best state of nature. The other approach is the conservative approach, and it evaluates each decision alternative in terms of the worst state of nature that can occur. The decision alternatives recommended is the one that provides the best payoff in the worst state of nature. And here we see the payoff tables for weak demand. That's the worst state of nature for the Pittsburgh Development Corporation. And the maximum payoff in the weak state of nature is 7, building a small complex. So taking the conservative approach, we would spend for a small complex and net a $7 million payoff. And now we'll take a little bit more in-depth look at expected value. So in decision-making situations where probability assessments for the states of nature are available, we can use the expected value approach, as we did in Part 1 of our Chapter 15 lecture, to identify the best decision alternative. And the expected value is the sum of weighted payoffs. So it's a weighted average approach. And we take the payoffs for each of the branches, small, medium, large, strong, and weak, and we calculate the weighted average by multiplying the probability. So in the case of a small complex, the net payoff would be 8 for a strong demand, and there's an 80% chance of a strong demand, so 8 times 0.8 is 6.4. And then multiply that, or add that to the payoff for a weak demand branch for the small project, which would be 7 times 0.2, which is 1.4. Add the two together, 6.4 and 1.4, and you get 7.8. And likewise for the other probabilities. So here we see where we've collapsed the graph, the decision tree, because we've calculated the expected value for the strong and weak demand. And now we're just looking at the expected values of the 3 branches from the decision to what size complex to build. And for our situation here, it would be to build the large complex with an expected payoff of 14.2. So the weight for a payoff is the probability of the associated state of nature, and therefore the probability that the payoff will occur. So we select the decision branch leading to the chance node with the best expected value. This decision alternative associated with this branch is the recommended decision, so large in this particular case. In practice, obtaining precise estimates of the probabilities for each state of nature is often impossible. So historic data is preferred to use for estimating the probabilities for the different states of nature. So risk analysis helps the decision maker recognize the difference between the expected value of a decision and the actual payoff that occurs. The decision alternative and a state of nature combine to generate the payoff associated with the decision. A risk profile for a decision alternative shows the possible payoffs along with their associated probabilities. Now we're going to extend the model that we did with expected value in part 1, in the video we had for part 1 of chapter 15. And we're going to extend it by adding sample information. So what we mean by adding sample information is decision makers have the ability to collect additional information about the states of nature. So they originally did their study and came up with 80% likelihood of a strong demand and 20% likelihood of a weak demand. And they could do they could spend more money and do a more comprehensive study and come up with additional information about the states of nature. And that additional information is going to be obtained through experiments that are designed to provide sample information about the states of nature. The preliminary probabilities that we had, 80% for strong demand, 20% weak demand, is known as the prior probability assessments for the states of nature. And that's the best probability they had prior to obtaining additional information. Posterior probabilities are revised probabilities after obtaining the additional information. So as an illustration, for Pittsburgh Development Corporation, management's considering a 6-month market research study designed to learn more about potential market acceptance of the PDC condominium project. And they're anticipating 2 results. The first is a favorable report, which means a substantial number of the individuals contacted express an interest in purchasing a PDC condominium. The second result would be an unfavorable report, where very few of the individuals contacted express interest in purchasing a PDC condominium. A decision strategy is a sequence of decisions and chance outcomes in which the decisions chosen depend on the yet to be determined outcomes of chance events. So let's take a look at our model and how it's going to change as a result of this. And let me just make sure I'm lined up well. It looks like it for my video recording. So this is a model for the expected value approach that we used in the last lecture, part 1 of chapter 15. But we're adding additional information this time. So let's come down. This is a fairly large model. And the additional information we're adding is a market research study. So we have a decision to make initially before we even decide if we want to do a small, medium, or large complex. And the first decision we have to make is, do we want to conduct a marketing research study? So we have 2 branches from that. One is that we do want to conduct a market research study, and the other is that we don't. If we take a look at the branch that we get for our decision tree if we do not do market research, it's exactly the same as the decision tree we had in part 1. So we went over this in depth in the video lecture for part 1, but this is exactly the same decision tree. And it feeds us exactly the same result. $14,200,000 is the expected value. So if we choose to do a marketing research study, the results of it will change our probabilities and therefore our expected values. We also need to assign probabilities to the favorable or unfavorable report. In the next section, we'll learn how we can use Bayes probabilities to derive this from the prior probabilities and the conditional probabilities that are essentially the accuracy of the market research firm. Right now, let's look at the structure of the model. So again, we have this decision to do the report or not. If we do, we have a chance event. So let's say we've chosen to do, let's go to the upper branch here, we've chosen to do the marketing research study. Now we have an additional chance branch. We could be a favorable report. In other words, the marketing research company tells us, yes, it looks like this is going to be a good opportunity. They could also give us an unfavorable. No, it doesn't look like demand's going to be there for this. So Once we get by that decision, then the chance node, then we have a decision to make: small, medium, or large. And of course, then our chance node of strong or weak demand. So the bottom fork that we just looked at is here, no market research. So we're back where we were with the first model we looked at in part 1 of this chapter. We just have a decision, small, medium, large, and a chance node, weak or strong demand. And again, we did this in the first part of the lecture. Now let's look at the upper half again. And the upper half of the overall model is what we add because of the sample information. So this is a graphic of what we see in our Excel spreadsheet. And again, we've got the bottom branch is what we did in the first lecture. The top branch is the new information, market research study. There's a chance node for the type of report, favorable or unfavorable. And then we're back to the same structure we had in part 1, the decision tree, except the probabilities are different because we have additional information. So in the bottom branch, you'll see 80%, and in the top branch, 94% for strong demand. And we'll see how we calculate those when we get to the Bayes probabilities. So what we do next is we start calculating expected values. We start with the rightmost chance nodes, and we're going to just do the weighted average, 0.94 times 8 plus 0.06 times 7. Likewise for each one of them, we calculate the expected values. So let's see this in action. Let me again make sure we're lined up well. Okay. So we've got our payoffs, and this, of course, from the payoff table that we started the whole problem with. And now we've got our new probabilities, and it's 0.94 and 0.6. Our expected value is going to be, as we see up in the formula bar, the weighted average of those two branches. So it's going to be 0.06 times 7 plus 0.94 times 8. And likewise for each one of the branches. So here, again, you'll see I'm using the appropriate cells to multiply 0.94 times 14 plus 0.06 times 5. And here, same thing. Then once we've calculated the expected values for our 3 branches, the expected value for the favorable report will be the maximum of those 3. So we take the function max of T1, T11, and T17, and what we get is 18, which is the large. So if we get a favorable report, according to the probabilities we have, the best decision would be a large condominium complex. On the other hand, if we look at the unfavorable branch of the report, we get a different set of probabilities, but we use those to calculate, our expected values just as we had done before. So each of these is the same type of calculation. You can see up in the formula bar here, that's the case. and up again. So once we have those three expected values for the three branches, small, medium, and large, then the expected value for an unfavorable report will be the maximum of those three. So it'll be 8, the medium branch. Then the expected value of the market research report branch is going to be the weighted average of the favorable report and the unfavorable report. Now, management has done a study of this market research firm, and they found that 77% of the time they issue favorable reports, and then 23% of the time unfavorable. And so they use that in the calculation of the expected value for the marketing research report. And so it's 0.77 times 18 plus 0.23 times 8 gives us 15, right there, 15.93. Now, we'd already calculated the expected value of the no marketing research. Of course, this is what we did with our initial, more simplified model in part 1, and we came out with 14,200,000. So, the overall decision is do a marketing research proposal, and your expected payoff is going to be 15 million, because we're going to take the max of either marketing research or no marketing research. So here we see we're collapsing down our branches, and here we've done the expected values of the strong and weak demand, and now we've got the three expected values for our decision on the outer right side of our decision tree. And we'll keep collapsing down by computing expected values. Then we get down to we've collapsed it even one more level by taking the maximum and getting our expected values there, and then computing the expected values of the favorable report and the unfavorable report, and that'll eventually take us down to the point where we have a marketing research expected value and a no market research expected value, and then we can make a comparison. So let's return to our model. Now, the value of this market research is the difference in expected value for doing the marketing research, which is 15,930,000. It's the difference of that from the expected value if we did not do the marketing research, which is 14,200,000. So the difference between those two is 1,730,000. That's the value of doing this marketing research study. Oops. So again, we keep collapsing down. We collapse down the favorable and unfavorable to get the expected value of that. And then we've got the difference between the payoffs for marketing research study and not doing a marketing research study. So the overall conclusion for Pittsburgh Development Corporation: if you get a marketing research report that's favorable, construct a large complex. If you get a marketing research report that's unfavorable, then conduct the medium complex. And here is just a slide on how we determine the value of the marketing research. And it's again just taking the expected value for doing the marketing research and subtracting the expected value if you don't do the marketing research. And in this particular case, it turns out to be 1,730,000. That's the value of that report. And we looked at that already. Okay, let's press on here. So we had some probabilities that we gained from the additional information provided by the marketing research studies. And that caused us to change our probabilities from the 80%, 20% to a set of probabilities, 90% and 94% and 6% and 35% and 65%. And they were at appropriate places in that particular decision tree. And we'll take a look at it again in just a moment. But first, let's just go through as a refresher the notation for Bayesian probabilities, because Bayesian probabilities is what we'll be dealing with here. So the pipe symbol, or that straight line, is the notation that's read as given. So we have the probability of strong demand given a favorable report. And of course, that was 94%. And then the other probability is the probability of weak demand given that we have a favorable report. So they're not going to be 100% right. In this case, that's a 6%. So 6% of the time they get it wrong. So this indicates a conditional probability because we're interested in a particular state of nature. And we're going to condition it on some additional information, a favorable report. So this probability of a strong demand given a favorable report and the probability of a weak demand given a favorable report are posterior probabilities because they're conditional probabilities based on the outcome of the sample information. So let's take a look at the worksheet again. This time we'll have the calculations for doing the prior probabilities, the sample information, and then the posterior probabilities. So I'll bring that up. And again, let me just make sure this is properly lined up, and it does not appear to be. So hold on just a second while I pull some of this information over. Okay, now let me take a look. Okay, now we have it. Okay, so let's go forward. So we start off with the same model as in the last example with a marketing research report. But this time we're going to show the calculations of the branch probabilities right next to the payoffs. So at chance nodes 6, 7, and 8, right up here, we have two repeating probabilities that we need to calculate for each of the three decision branches. The probability that we will have strong demand given that we have a favorable report, and the analog of that probability which is weak demand given a favorable report. These are conditional probabilities that, again, we discussed in Chapter 5 about 6 weeks ago. And they're called posterior probabilities because they're conditional probabilities based on additional information. So we had some prior probabilities, we get some new information, and then we're going to calculate posterior probabilities. So some of the things we need to do this calculation are PDC's assessment of the probabilities for the two states of nature, strong and weak, that they started with. And of course, this was a given in the problem, and it's the probability of a strong demand is 80%, we see right here. Probability of a weak demand is 20%. Again, we see it right there. So this is what they originally came up with their initial survey, not as in-depth, but it gave them a sense of what the potential market was. So we need, of course, those, and we also need the additional information. And the additional information we want to add in is what's the accuracy of this firm. So if they do this study and they come out with a favorable report, how often does that favorable report result in strong demand? And how often is the favorable report wrong and we get weak demand? So, and then likewise, they come out with the probability of unfavorable report, yet you do have a strong demand, and the probability that you come out with a favorable report, but you have weak demand. So this is really an assessment of the firm's accuracy. So to use the Bayes theorem to determine posterior probabilities, which is these branch probabilities that we want to use to compute our expected values, we need the first set of expected values to be driven by these posterior probabilities. And then that will affect, as we collapse all the way down, that's going to affect all the resulting expected values and comparisons. So we need two things to calculate those: the prior estimations of strong and weak demand, and then we need the probability of a favorable report given that strong demand did occur, and likewise the probability of an unfavorable report given that strong demand did occur, and then the same with weak demand. Well, this is historic information. We can go and look at the firm's record and we can see how well they are at predicting this sort of market. And of course, Pittsburgh Development Corporation did just that, and they came up with 90% of the time when the firm predicted a favorable report, there was strong demand. But 10% of the time, when they predicted an unfavorable report, there was strong demand. And 25% of the time, when they predicted a report that was favorable, weak demand came out at 25%. And same thing with the unfavorable for weak demand. So, with that historical information, weak demand and how many times when you had weak demand, what percentage of the time did they issue a favorable report, and what percentage of the time did they issue an unfavorable report? Well, for weak demand, it was 25 and 75, and likewise for strong demand, they 90% of the time said it was a favorable, they gave a favorable report, 10% of the time they gave an unfavorable report. So that's the firm's accuracy, and it's a conditional probability, but it's the conditional probability we need. So if you'll recall from both Chapter 15, they went over Bayes' formula, and also Chapter 5, we did the same thing. So in red, we see the posterior. This is what we're going to calculate from the sets above. So these probabilities here are just givens. We do them from research on the firm's record and the management's initial estimates. Here's where we do the Bayes calculation. And that's going to be for the probability of strong demand, given that we get a favorable report, is going to be equal to the probability we have a favorable report given that there's strong demand times the probability that there's strong demand divided by that very same factor plus the probability that there's a favorable report and we had weak demand times the probability that we have weak demand. And so you see that in the formula bar, and those are the cells that are for that particular multiplication. And the result is 0.94. So 94% of the time is what we can expect. A 94% probability that, that if they give us a favorable report, we'll end up with strong demand. And that's reflected in this branch probability here. And that's what we multiply by the payoff here. And let me just make sure it's lined up. Yeah, okay. We do the same sort of calculation for each of them. In other words, we're going to multiply the appropriate firm accuracy times the appropriate demand, probability for demand, strong or weak. And then we're going to divide that by the same factor in the numerator plus the opposite side of it. So if we're looking at weak demand, then we're going to add in the probability that we get strong demand in the denominator and divide through by that. So we do that for all of these, and we come out with these branch probabilities. 0.9 or 94% strong, 6% weak, given a favorable report. And then let's go down. For the unfavorable report, we get 35% probability strong demand, 65% probability weak demand. And again, this is just from applying Bayes' theorem to information we already have at hand. The historical record of the marketing research firm and management's initial survey into the situation. So as mentioned, we use the prior probabilities, those given in the problem by management, and with both sets of data, prior probabilities, and the accuracy of the firm, we can calculate the necessary posterior probability, the probability we have strong demand given a favorable report. And of course, that's what we did. This particular exercise is just to show you where they came up with these numbers, 94 percent and 6%. And then how they would do it. They'd have their initial survey and study that may not have been as expensive and comprehensive, but they got 80-20. And then they wanted to see, well, what's the payoff for doing a more extensive market research? Well, you look at the firm's accuracy, and it's going to be conditional. Probability of a favorable report, given that the data shows that the end result was a strong demand. Probability of an unfavorable report, given that the data shows ultimately the demand was strong. Okay. So it shows here with the model, you'll see, notice that in this model, this depiction of the model, they don't give the 0.94, they give the posterior probability. The probability of strong demand given a favorable report for the top branch, for example, here. And then let's go down to the bottom branch. The probability of strong demand given an unfavorable report. So these are the posterior probability equations we see, just to show you that, you know, this is how we calculated the numbers we had in those particular spots in the previous graphs. And as mentioned, when we're computing these things, we need the prior probabilities and also the conditional probability of the market research outcomes given each state of nature. In other words, the accuracy of the market research firm. But I guess the more precise term in terms of analytics is the conditional probability of the action outcomes given each state of nature. And in this case, the action outcomes was the marketing research outcomes. And then finally, last slide for the course is just a presentation of Bayes' theorem. And we can see that's in chapter 15, and it's formula 15.5. It was also a formula in chapter 5, and we went over this. And in fact, it was on the midterm, so I wanted to get you guys used to the idea. Okay, thank you.